This is the Geomagic for SOLIDWORKS training file number 13, an end-to-end mechanical reverse engineering workflow. Do a new file and import using the plugin number 13, the end-to-end mechanical. And this is a file that's in millimeters, so we're going to change our units upon import. We hit open. We should be able to right-click and edit the feature to ensure that we have a bounding box size of about 4 by 3 by 3 inches. If you've got something that's different than that, your units were set incorrectly. So again, I definitely recommend getting in the habit of checking your bounding box size before you begin to model. This is a single STL file. There are not multiple files in it, so we don't have to go through the process of doing any scan data editing or any scan-to-scan alignment. And since I'm doing a mechanical workflow, I don't even need to go fill all of these holes. I can model around them using the data that I do have. If I show my front, top, right plane and origin, I can see that this part has not been oriented to the world yet. So we'll start our modeling process off by doing exactly that. To make working with the scan data a little bit easier, I'm going to region group this part. And I'm going to try the default options. We'll see what we get. So it looks like for the most part it was okay, but I don't see a differentiation between the lower cylinder here, the fillet, and this top plane. So I am going to deselect my preview, increase my curvature sensitivity, and I'll decrease my connecting region width a little bit because I do want to see some unique regions down at the bottom here. Hit preview again. And it looks like I still need to add some sensitivity, so we'll do this one more time with the maximum. And you can see how as I increase the sensitivity, I do get an increased number of regions until the point where it looks kind of like camouflage here. But this is okay, we'll be able to work with this. If I did want to, I could delete the separation between a couple of regions to merge them together. But that's not necessary. So we'll go ahead and start our alignment process by using the reference axis tool to extract an axis from some of the cylindrical regions on the interior of our part. We'll do the same thing with the reference plane tool. I'll select a couple regions on the base and hit OK. We do have a symmetry plane that we can extract from this part, so if I rotate this up to a top view, I can use my symmetry plane to manually draw a line close to the axis of symmetry that I want, and then hit preview to see the calculated image. If we do want to constrain our origin to be at the intersection of this plane and our axis, we need to build that like we did before with the reference point tool on SOLIDWORKS' Features tab. I'll use the intersection method between my plane and my line. And now I'm ready to go back to the Geomagic for SOLIDWORKS tab and orient my mesh. We're going to use a reference geometry selection to select our origin and fix our point. Use our Z-axis and select our base plane here, and then select our X-axis and our center line plane. When we hit OK, our scan's going to move, but those reference geometries are not. So I can select just the reference geometries, delete them, and recognize that I've got my front, top, and right plane all in the correct location. We'll start off the modeling process by extracting a cylinder from the main outer regions of our scan here. We're going to force this to be parallel to the world, so I'll choose my rotation axis and lock it to the normal vector of my front plane. I also want to make sure that the cylinder that I build is taller than my model, because I'm going to trim away some of this excess later, and I do want to make sure it does connect with this base that I'll design in a later step. To remove the top of this cylinder, we'll extract a plane, and I should be able to grab a couple of these regions to extract a reference plane. Actually, this is a feature plane, not a reference plane. And I'm going to use the cut result operator and the enlargement slider to ensure that the preview plane that I get is larger than my cylinder, and that the arrow in the center here points in the direction of the portion of the cylinder that will be removed. When I hit OK, we build a surface plane, and it cuts away the top of my cylinder there. We'll complete that feature by right-clicking one of the edges here, and we'll use SOLIDWORKS' filleting tool to add a radius to the outside of this feature. This is where we get into kind of an iterative modeling approach, where I can use the preview to help guide my radius that I establish. And I can say, well, 1/4 of an inch looks about right. I'll build it and then use my deviation analysis to check if that radius value is appropriate. If my colors are red like they are in this image here, that indicates that my scan data is lower than my CAD model. My CAD model there's too much material there, and I need to remove more of it, so I need to increase my fillet radius. So I'll exit the analysis tool, right click and edit my fillet feature, and I'll type in a different value, 0.3 this time. That looks like it's a bit closer to the scan data, so I'll go back to my deviation analysis, select the body, hit preview, and I am in fact a good amount closer. I'm still off by about 40 thousandths or so at a maximum, so I'll add that to my radius. Build it and go back into my deviation analysis one last time. And that looks like it's very accurate. We'll continue our modeling by building our base area here, which is just a square with 4 fillets on it. I'm going to create a cross section and put that cross section on my front plane. Now I'm going to need to offset that slightly into the part, so I'll add a small value and flip the direction of offset so that I can see good clean black lines intersecting my scan data. In this case, I'm going to build that just as a polyline. And then I let the software build that cross section, and I can hide my mesh, hide my solid body, and enter that sketch to edit it. I'm going to orient normal to plane, and I'm going to trace the required geometries with normal SOLIDWORKS sketch entities. So I'll build a rectangle, and then I can drag the arms of that rectangle, or the sides of it, to match the cross-section polyline beneath. If I want to, I can create relationships to the polyline as well. This will result in better accuracy. I can also dimension in this step. If I want to constrain the dimensions here, maybe instead of 3.26, I'll make it 3 1/4. And this adds design intent back into the model. Now I can take that sketch and use the SOLIDWORKS extruded boss base to extrude it up. Unfortunately, I can't show my scan data while I'm in this tool, so I need to cancel out so I can see what or where my scan data exists. And I'm going to show my existing solid body as well so that I can merge this new body with my existing one. So we use the extrude tool, select our sketch, and I need to recognize that because I offset my cross section, I do need to offset back down to my original plane. So I'll actually use the up to surface option and select my front plane to cap my extrusion in one direction, and go the opposite direction to the point where I extrude up to that surface. I'll merge this with my cylinder, hit OK, and if I hide my scan data, I can see the base has been added. Now I do need to fillet those 4 corners, so like before, I'll right click one of those edges, select the fillet tool, and I can select the other 3 edges in turn so that I add the same radius to all 4. I'll use the scan data to help me guess a radius here. It's not quite a half. Looks like a 3/4 radius fits that data very well. And I'll hit OK to add those fillets. We'll add the side bosses next, and we'll do this with a extrusion wizard, actually. If I go back to my Geomagic for SOLIDWORKS tab and I view this object from the side, we're going to work on this feature here. I'm going to turn off my region colors and use the extract extrusion tool to extract an extrusion from this feature. I'm going to do that by making a general selection and using my rectangle selection tool to select a sliver of data inside of this zone. I need to make sure that I have my select through on, because I don't in this case. So if I turn on select through, box select through my area, I notice that I'm making a nice clean selection through that feature, and I'm going to extend it up to this surface, and I need to move this back till it extends through the other. Now, I do need to constrain my sketch plane, the normal vector, to something that's parallel to it. So my top plane, my system plane here, will work well. And now I can say extend out to that surface and back out to that surface. In this case, there is an internal geometry here that's being selected. I'm going to go ahead and keep that for right now. So it looks like we accidentally did a cut and not a extrude. So I'll just simply delete the extrusion feature and go back to my features tab here, use the extruded boss base to extrude just the feature that I want. If I edit that extrude, I can ensure that the value matches what I need. I'll repeat the process on this side. Use my extract extrusion tool. Align my view. And in this case, if I wanted to ignore that central cylinder, all I have to do is use the control key and make a new selection to cut out the interior geometry so that the extract extrusion tool only builds solids from the outer portion here. So I'll make sure that this body extends all the way into the solid, and I'm going to change my result to join this time, which was the mistake that we made last time. Use the normal again from the top plane to constrain the direction of my feature, and hit OK. These tools will help us create the remaining geometries that we need. In this area, I'll extract one cylinder using my regions to help. And this is a cylinder that I can constrain to my top plane. I want to make sure that this passes and merges all the way into my existing bodies. And to create this top feature, I'm going to build a reference plane on the top of this cylinder. Using this reference plane, I can take another cross section and when I edit this cross section, I can see that I've got much more data in here than I actually need. But the feature that I'm trying to build is this slot feature, and SOLIDWORKS has a slot tool where I can build a vertical slot centered around the origin. If I show my mesh, we can use our features extrude to extrude that into a new body. Like before, we can use the extract cylinder tool to build a cylinder here. We'll constrain that to the front plane. We'll do the same thing here. and build a final cylinder using this region and that one. Making sure that it extends all the way into the part. So here's where we are at this current point. Most of the geometries are created, at least on the external portion. If I show my scan data, I can see that there is a CAD face in here that needs to be chamfered. So we'll hide our scan data, right click that edge, and use our chamfer tool to add a 45-degree chamfer. And actually 45 degrees looks a little too steep, so we'll edit this now with our scan data shown. Until we get the preview to look correct. We'll take a look at our deviation analysis, select our body view, and with the exception of some small fillets and these pads, we're doing quite well. The rest of the part can be modeled with the same tools. So we'll end the lesson here.